Welcome to the class of Advanced Stats and Econometrics. In today's lecture, we are going to discuss exploratory factor analysis. The learning objectives of this course are: first is differentiate factor analysis techniques from other multivariate techniques. How factor analysis techniques are different from other techniques. Distinguish between exploratory and confirmatory uses of factor analytic techniques. And understand the 7 stages of applying factor analysis. Distinguish between R and Q factor analysis. Identify the difference between component analysis and common factor analysis models. So, further objectives are basically you should be able to tell how to determine the number of factors to extract. What are the bases? On what basis you can decide how many factors to extract? Explain the concept of rotation of factors. Describe how to name a factor. Explain the additional uses of factor analysis. State the major limitation of factor analytic techniques. So factor analysis define exploratory factor analysis. It is an interdependence technique whose primary purpose is to define the underlying structures among the variables in the analysis. What is exploratory factor analysis? It examines the interrelationship among large number of variables and then attempts to explain them in terms of their common underlying dimensions. These common underlying dimensions are referred to as factors. A summarization and data reduction technique that does not have independent and dependent variables but is an interdependence technique in which all variables are considered simultaneously. So let us look at this correlation matrix for store image elements. So there are 9 variables for this store image elements. First variable 1 is price level, second is store personnel, third is return policy, variable 4th is product availability, 5th variable is product quality, 6th is assortment depth, 7th is assortment width, 8th is in-store service, 9th is store atmosphere. So if you look at the correlation matrix, the diagonal elements all are 1, which means the correlation between the same variable with itself will be by definition 1. But if you look at lower triangle matrix, so all the lower elements below this diagonal element, which is 1, are mentioned, and upper values are left blank because the values will be same. So correlation between V1 and V2 will be same as V2 and V1. Now look at this correlation matrix of variable after grouping using factor analysis. So once we look at which variables are highly correlated so that one factor can capture variation in these variables. So if we are looking at the 4 V3, V8, V9, V2, variable 3 return policy, in store service, store atmosphere, store personnel. These 4 are having high correlation. And the second set, so basically we expect that one factor will capture variation in all these 4 variables. Then variable 6, 7 and 4, they are likely to be, they are highly correlated, so we expect that another factor will capture variation in these 3 set of variables. Variable 1 and 5 are highly correlated, so we expect that the third factor will capture variation in variable 1 and variable 5. Factor analysis decision process. Objectives of factor analysis, that is stage 1, stage 2 is designing a factor analysis, stage 3 is assumptions in factor analysis, stage 4 is deriving factors and assessing overall fit, Stage 5 is interpreting the factor. Stage 6 is validation of factor analysis. Stage 7 is additional uses of factor analysis results. Stage 1, objectives of factor analysis. Is the objective exploratory or confirmatory? Specify the unit of analysis. Data summarization and or reduction using factor analysis with other techniques. Factor analysis outcomes. Data summarization, basically deriving the underlying dimensions that when interpreted and understood describe the data in a much smaller number of concepts than the original individual variables. Data reduction. Extend the process of data summarization by deriving an empirical value, factor score or summated scale for each dimension factor and then substituting this value for the original values. Types of factor analysis. There are two types of factor analysis. One is exploratory factor analysis and another is confirmatory. Exploratory factor analysis is used to discover the factor structure of a construct and examine its reliability. It is data driven. Confirmatory factor analysis is used to confirm the fit of the hypothesized factor structure to the observed sample data. It is theory driven. So designing a factor analysis, that is part of the stage 2. Three basic decision: calculation of input data, R versus Q analysis, design of study in terms of number of variables, measurement property of variables and the type of variables. Sample size necessary. Factor analysis design. Factor analysis is performed most often only on metric variables. Although specialized methods exist for the use of dummy variables, small number of dummy variables can be included in a set of metric variables that are factor analyzed. If a study is being designed to reveal factor structure, strive to have at least 5 variables for each proposed factor. For sample size, the sample must have more observations than variables. The minimum absolute sample size should be 50 observations. The maximum number of observations per variable with a minimum of 5 and hopefully at least 10 observations per variable. Assumptions of in factor analysis is stage 3, the basic decision. Calculation of input data, R versus Q analysis, design of study in terms of number of variables, measurement property of variables and the type of variable, and sample size required. Assumption is, one of the assumption is multicollinearity. So this is assessed through MSA measures of sampling adequacy. MSA is measured by Kaiser, Meyer, Olkin, KMO statistics. As a measure of sampling adequacy, the KMO predicts if the data are likely to factor well based on correlation and partial correlation. KMO can be used to identify which variables to drop from the factor analysis because they lack multicollinearity. There is a KMO statistics for each individual variables and their sum is the KMO overall statistics. KMO varies from 0 to 1. Overall KMO should be 0.5 or higher to proceed with factor analysis. If it is not, remove the variable with the lowest individual KMO statistic value 1 at a time until KMO overall rises above 0.50 and each individual variable KMO is above 0.50. Homogeneity of sample factor solution. Stage 4 is deriving factors and assessing overall fit. So selecting the factor extraction method, common versus component analysis. This is part of deriving factors and assessing overall fit. Determining the number of factors to represent the data. So we are going to determine how many factors we are going to select, and that is part of the stage 4. So today we are going to stop, and the reference for all this is a book titled Multivariate Data Analysis, 8th edition. Publisher is Cengage Learning. Authors are Hare, Babin, Anderson, Black. Thanks. That's it for today.